Good evening, everyone. Thank you for joining us tonight for our Zoom program with Professor Ted Hayduck of NYU. I see some familiar names in the audience tonight and some new ones, so I am glad that you were all able to tune in, and I'm sure that that number is going to keep creeping up because we have about 50 people registered for this lecture tonight. I'm going to go ahead and introduce our speaker. Our program tonight is Changing the Game, Sports, Artificial Intelligence, and Machine Learning. We welcome, like I said, Ted Hayduck, who is an assistant professor at New York University's Preston Robert Tisch Institute for Global Sport. He is a former consultant to the MLB, and his current research focuses on innovation and entrepreneurship, particularly in the context of business analytics. His work has been published in high-quality academic journals, including the International Entrepreneurship and Management Journal, the Journal of International Trade and Economic Development, Organizational Dynamics, and the International Journal of Entrepreneurship and Small Business. We are fortunate enough to have Professor Hayduck be able to answer a few questions at the end of tonight. So I ask that if you have any questions, you can hold them to the end, and we're going to be using the Q&A feature of Zoom. So go ahead and put your questions in the Q&A versus the chat tonight. And without further ado, I will give you the floor.
Well, hi, everyone. It's great to be here. Kayla, thank you for that wonderful and very formal sounding introduction. I don't take myself nearly as seriously as some of the titles of our academic journals would make it seem. So I hope that, that this evening is fun and engaging for everybody. And let's see, without further ado, I'm going to go ahead and pull up my presentation here. Okay, so hopefully you all can see my title slide here. And without further ado, let's jump right in. And like Kayla said, I'm going to make sure and try to finish up here with about 10 to 15 minutes left. But before we dive in, I do want to say again, just to thank you all for being here and for supporting your public libraries. As I was telling Kayla before we got started this evening, my grandmother was a public educator, and so she, you know, for 40 years supported everything that public education and discourse and all these great things that that libraries are really built around and stand for. So really happy to be included in your series. And without further ado, I'll jump right in. So tonight we're going to talk a little bit about artificial intelligence and machine learning in the sports and entertainment industry. And in order to do that, we're going to talk a little bit about some terminology, and then we're going to talk about AI and ML and where they're being deployed in other industries currently. We'll talk about why sports and entertainment is particularly interesting for using these technologies and talk about some of their current uses. And at the end, we'll talk about where sports and entertainment is really leading the pack in terms of business evolution, innovation, and entrepreneurial activity. And at the end, I'm going to share some resources related to machine learning and artificial intelligence that I think are really accessible, and they were a big part of the beginning of my journey into this subject matter. And I always take the opportunity to recommend some of these resources here. So I'll do that at the end. So if you've read a little bit about machine learning or artificial intelligence, or you've even heard the buzzwords, you've probably heard a lot of these ancillary terms, right? Statistics and analytics, algorithms. They all kind of seem somewhat amorphous when they're discussed in the news or when they're discussed in even in a lot of academic context as well. So we'll go through them a little bit and just kind of really be careful to delineate what it is we're talking about. So first two terms I want to talk about are statistics and analytics. Now, statistics has been around a lot longer than the analytics terminology, but as you can see here, we started to see analytics make a name for itself somewhere around 2005. And you saw the increase of the term analytics coupled with the decrease in the term statistics, right? And this is data from Google search. And so over the past 15 years, you can see that these two terms have really sort of grown together and they're used interchangeably. So if you were to study business analytics, or if you were to take an analytics class here at NYU, what you would be learning is statistics, right? That's the underlying mechanism. So you can see here, there's a little bit of a jump in statistics as of late, and my guess would be that has to do with people searching for like COVID statistics or something along those lines. But other than that, you can see that these two terms are, after about 2010, they're really used interchangeably. So when it comes to these two terms, we have two worlds of statistics and analytics. The first is descriptive. And when we are describing data, we're talking about a single characteristic of that data. If you think about a bell curve and the distribution of anything, right? Could be height, could be weight, could be mileage driven, right? You have statistics related to central tendency, for example, and these are things like mean, median, mode. So to go back to, let's say, fourth or fifth grade math class, right? And then you also have statistics and analytics that describe dispersion. So the spread outness of that distribution. Those would be things like variance and standard deviation. Now, again, these are just descriptive, but they're still technically analytics, okay? Where we get more technical is when we get into the world of predictive statistics or predictive analytics. And the reason this gets more complicated is because now we're not just talking about one variable and the shape of one variable, we're talking about relationships between multiple variables, at least two variables. So if you can think back to maybe like sixth or seventh grade linear regression, or maybe later on in your high school or college career, if you took calculus, right, you probably at some point came across this equation y equals mx plus b. And all that equation does is it conveys to you what happens to y if you change x, right? And that reactionary relationship between x and y is what we're mathematically quantifying with that equation. So if I were to increase the amount of hours that I practiced my sport, right? I grew up playing golf. If I were to increase the amount of hours per day that I played golf and practiced golf, what would happen to the y? The outcome would be my score on the course, right? You would think that if I increase the amount of practice hours, I should decrease my score, which is a good thing. Okay, so the crucial point about the terms statistics and analytics is that as the researcher, you have to guess about the mathematical relationship between x and y, and you have to specify that beforehand, before you do an analysis. So it's a manual process, right? That's why in academia, the traditional experimentation, right, the scientific process makes use of developing hypotheses and using statistics to test those hypotheses. So it's a manual process that's executed by the researcher. Now, what you wind up with after engaging in a predictive analytics or a predictive statistics exercise is something that looks along the lines of this plot right here, right? We have our x variable on the horizontal axis, and it can be any potential x variable. Maybe it's our amount of hours per week that I practice golf, like I said earlier. And then our y variable is on the vertical axis. And we can see our blue data points are plotted there. And the red line is the line of best fit. That means that's the line that when you trace it through all those blue dots, that's going to give you the least amount of error. That means it's going to minimize all these vertical distances between the blue dot and the red line. That's your error. And so we want to minimize that as much as possible if we are going to make accurate predictions. So We'll kind of like diverge a little bit here and talk about this term algorithms. I think algorithms is probably the term that people and students that I've crossed paths with are the least familiar with, and it's because it's, I think, the broadest, right? And what an algorithm is it's just a step or a series of steps for helping you accomplish a task that's repeatable. So to keep with our, fifth and sixth grade math type of metaphor, right? If I were to solve the equation 8 equals 0.5x plus 23, there is a set procedure that I can use to solve that equation. And that set procedure is the PEMDAS order of operations, right? Please excuse my dear Aunt Sally. That's the mnemonic, but um, the steps that we're engaging are parentheses, exponents, multiplication, division, addition, subtraction. If we approach any um, any equation, any quadratic equation in with that specific set of rules and guidelines, we'll reach the correct answer. Okay. You could have an algorithm that has nothing to do with math, right? That's I think where people get lost thinking about algorithms, is that they don't have to do anything with mathematics, right? There's an algorithm for brushing your teeth. If you were to explain to an alien who showed up to your house tonight how they should brush their teeth, you would say, well, let's see, step one is to go into the bathroom where you keep the toothbrush and toothpaste. Step two is to locate both the toothbrush and toothpaste. Step three is to unscrew the cap of the toothpaste. Step four is to, put toothpaste on a toothbrush, and so on and so forth, right? And then you could take that algorithm, that recipe for brushing your teeth, and give it to anybody, and they could figure out how to do the same thing and reach the same conclusion. So that's the idea behind an algorithm. Now, the term artificial intelligence is important only in that it's what you would call the parent discipline of machine learning. And so because it's a parent discipline, it's broader, right? Machine learning is a subset of artificial intelligence. And so AI is really any technique that helps computers mimic human behavior. And there's a lot of different worlds of AI. It's a very broad field. But even using simple things like logic and, Boolean operators, which we can get into later on, but if-then rules, right? If, for example, if you're an automated if you're an automated machine that's supposed to drive a car, right, and you detect a human walking in front of you, if you detect human, then turn the brakes on, right, slam on the brakes. That would be just a really simple if-then rule that would technically fall into this really broad world of AI. And so here's a little bit of a visual to help that make sense a little bit. There's even a subset of machine learning, which we won't talk about tonight, called deep learning. But you can see when we get into machine learning, which is our next ring down the visual there, now we're starting to bring in statistical algorithms and equations that actually have quantified relationships between variables. So what's the relationship between machine learning and artificial intelligence? Well, as you can see, artificial intelligence has always been a broader field. That's why it's always been more popular as a search term in Google. But we also see that machine learning has really picked up, let's say, maybe about 2013 or late 2014 is when we started to see an increase. And we're starting to see that it's really undergoing a sea change, right? Nobody was really talking about it in 2004, 2009, 2010. Now, all of a sudden, nearly a quarter of every term that's searched related to these two terms is machine learning related. So it's a very rapidly growing field. Okay. Now, machine learning, right? This is the combination of two terms, machine and learning. We know what machines are. So let's talk about what learning is. How do we put some bounds on what learning is? The best way to illustrate this is to think about the process of every so often taking in new information about a subject that you have preconceived notions about, ingesting that information, and then modifying your prior beliefs. Okay, that's how in the computer science world and in statistics and in machine learning, we think about learning. The process of learning kind of involves or necessitates like an evolving um, worldview, right? And you can think about this. A good example that I like to use actually is if you think about toddlers, right? If you show a toddler a picture of a dog, right, and you teach it that that's what a dog looks like, you don't need to show that toddler all the different breeds of dogs. They just know that all of these things are dogs. Okay, and that's something that's very important actually about the human brain and our learning process, that even machine learning really falls short on. So if you were to teach, if you wanted to teach a machine learning algorithm how to identify a dog or not a dog, you would have to show it pictures of all the different dog breeds and then hope that over time it kind of learns to identify a dog from not a dog. The crucial thing about machine learning, and to an extent artificial intelligence, is that as a person that's implementing machine learning, you don't necessarily care about specifying this relationship beforehand. So you have your outcome variable that you care about, and you have the predictor variables that you care about. You put both of these into the machine learning model, and the job of the machine learning model is to automatically generate the ideal mathematical representation. So therein lies the difference, right? With statistics and analytics, we're thinking ex ante about this mathematical relationship and we're quantifying it beforehand. Machine learning's job is to quantify that relationship and really not have the researcher think too much speculatively beforehand. So why is this important, right? In machine learning, to keep with our example earlier of a nice kind of simple X and Y plot here, all of the different lines that you see on there are potential lines of best fit for those data. If you're a machine learning practitioner, you don't necessarily care about specifying the exact right mathematical relationship beforehand because you know it's going to change. The process of machine learning involves bringing in new data and modifying that line of best fits accordingly and doing it dynamically over time. So if you're a machine learner, you don't necessarily care what that equation is. You just want the machine algorithm, the learning algorithm, to do it in the background and to update it automatically. One thing to think about, and this is a nice kind of like cartoon that I tend to show my classes and people who are moving into the space, right? By itself, statistics is just a crack in the wall. Nobody really cares about it. It's kind of a boring topic. It's an old topic. If you dress it up enough and you garner enough of an audience, you can build out something that you could call artificial intelligence. But I think the tongue-in-cheek thing stays true here is that underlying all of these things, machine learning and artificial intelligence, deep learning, is a sound statistical foundation. Another way to think about machine learning, I like to use this as well, is this example of a man named Nigel Richards. And Nigel did not speak a word of French, but he memorized every word in the French dictionary and then went out and won the French Scrabble championship. Okay. Now he couldn't speak French, couldn't read French, but he memorized the so to speak, the corpus of answers and was able to win a tournament, right? And so that's the level of capability that a typical machine learning type of algorithm can do. So it doesn't understand the why, it doesn't understand the underlying mechanisms, but it knows how to produce correct answers if trained properly. That's the big caveat. Okay. So I think if you spent more than 6 hours involved with corporate America, you've heard these terms AI and machine learning, and They seem a little bit like buzzwords right now, and so we tend to think that they are everywhere, and they are. They are being used for a lot of really good practical purposes right now, but we're going to talk a little bit about why we can be somewhat skeptical about that. Okay. Um, we know that, for example, Amazon, right? If you look at the logistics industry, um, they are trying to own the entire value chain between ordering a product and having that product show up at the correct location at the correct time. That is an immense challenge, right? This is Amazon is a completely vertically integrated logistics company. And so in order to do that at scale, they've brought in just about every kind of technology, AI and machine learning included, to help them optimize this process of getting things from point A to point B as efficiently and as quickly as possible. And so that's a huge area for machine learning and artificial intelligence. Um, in the middle left there, right? If you've ever visited a website and you've been prompted to chat with someone in a chat box and to ask them about what's bothering you, or explain the problems that you're having, or what questions do you have, chances are you're talking to a robot. The really good AI and machine learning chatbots are so good that humans oftentimes have trouble distinguishing their responses from actual human responses. And so providing that level of customer care, customer support is a big deployment of AI and ML these days. Bottom left, if you've ever been on Instagram and you've had what seems like an uncanny advertisement for a product that you were just thinking about the other day, it's not a coincidence. Okay. These recommendation engines, which are designed to put the right ad in front of the right person at the right time in the right place, those are a huge, huge use of artificial intelligence and machine learning. Similarly, um, notifications, and these top right and bottom left, we can kind of group into one, which is, location and consumer specific data based recommendations. Let's see. So the personalization of customer service, right, to some extent. Public safety and surveillance, I think, is another huge area. So the more that we can use computer vision to decide, what's a car, what's a bicycle, what's a person, where's a traffic light, the more efficiently cities can run, right? This is a big part of smart cities, is optimizing traffic flow, optimizing foot traffic flow, and sort of making sure that everybody is getting around town as efficiently as possible. And so these are decisions that typically a human would make, but we're now allowing machines and algorithms to make those decisions for us, because they can ingest more data than our brains can, and they can do it fast, more quickly and more efficiently. Another big application in business right now is trying to decipher facts from fiction, right? This for the past 6 or 8 years, there's been a huge campaign related to disinformation. And if you look at what Facebook and Twitter and some of the other big tech companies are doing, they're putting a lot of resources into helping machines and algorithms decipher what's fake from what's a fact. And a lot of humans can do this surprisingly well, and even young people, children can do this surprisingly well. But it's a big challenge to get machines to do it well. So what this all comes down to is, on one end of the spectrum, it's helping AI and ML are helping managers make data-driven decisions. At the end of the day, that's a quick win. That's the low-hanging fruit that AI and ML can help us attack, because at the end of the day, we have more data than we know what to do with. If your company can digest that data optimally, and it can do it in a way that is useful to your managers based on firm-specific KPIs and so on and so forth, you can really enhance the ability of people to make better decisions, right? That's the first step. Okay, people are never excluded from this process. All these other things that I've spoken to really point to this theme of automation. And that's where AI and ML really shine, right? Making things more efficient, making marketing, more optimized. So now we don't have to have a person think about and use their gut judgment to figure out what's the right ad to place at this specific location to this person at this time. Now we have an entire data lake to help us and to help machines make informed decisions. The reason automation is so important is because it can help companies achieve scale and specifically economies of scale and efficiency in areas where we could never have imagined it before. Okay, think about customer service and marketing. Right before, these are very human based interactions. They're very rooted in psychology, and psychology is difficult to quantify, and it's certainly difficult to represent, right? But now we actually have data on all of these things, and we're now pretty effectively starting to automate the process of customer service, customer care, building relationships over multiple channels, which we'll talk about a little bit later. So at the end of the day, that's where AI and ML is shining in the area specifically of automation and scale up of new innovations. However, right at the beginning of the section, I sort of planted this scene, right? There are lots and lots of startups out there and lots of big companies that love to tout their use of AI and ML. But there are questions about the legitimacy of their deployment of these technologies. In other words, a startup or plenty of startups will oftentimes decide that they want to compete based on their use of AI. So they are the AI for investing. They are the AI for customer recommendations. They're the AI for, marketing deployment, right? And there's a difference between using a sophisticated deep learning or machine learning model as part of the core product versus using some sort of baseline kind of lower level statistical predictive modeling approach to accomplish a task that's ancillary to their main product. And so oftentimes it's difficult to decipher the legitimacy of startups and sometimes with big companies, their use of AI and ML. So we'll move now into sports and entertainment. This industry is a great testing bed, I think, is what this conversation comes down to, right? Why is it taking off in our industry? And it's because there's a lot of empirical control that you can exact. There's not a lot of difference between, a Premier League soccer club in England and a Premier League soccer club or an upper tier soccer club in an adjacent country, right? In France and Spain. Brazil's soccer club is basically the same. The soccer going experience doesn't differ marginally across all these things. Watching sports on TV is very similar, right? And there's a lot of generalizability and transferability there. The industry also operates faster than any other industry, right? Because it's digitally native, right? We have this whole industry that's built on digital distribution of a product all around the world instantaneously, right? I can hop on Twitter right now and find broadcasts of sports that I didn't even know existed, even in the midst of a pandemic, right? What's also nice about this industry is that it's pretty low risk, generally speaking. If you're using machine learning to, let's say, forecast how worn down a soccer player is going to be after playing 90 minutes of soccer, It's not as high risk as if you were doing that, let's say, for other forms of manual labor in other industries where you're actually putting employees in physical harm by working them too far. In a soccer game, you can always take them out, you can sub them for someone else, and really the cost of doing that is not high. So the other thing that's nice about this industry is that from a technology perspective and an urban development perspective, stadiums really are like little cities, right? And we'll get to that in a minute, but they have everything that a city has just boiled way down. And so if you want to test a new concept, a new technology, a new idea, if you want to do it generally at a smaller scale, stadiums are a great environment to do that. And then also, for a fact that there's going to be a lot of data, and when that data is coming in. That games are going to happen once a week or every other day, if you're a baseball or basketball fan, and exactly when you need to ingest that data, and exactly what you need to do with that data, because it's the same data points that you're collecting for God knows how many weeks prior to that. And so it's a very simple and easy, repetitive data gathering process. So there's a lot to like about this industry. Currently, there are any number of areas where AI and ML are just really revolutionizing sports and entertainment. And I think, a topic that lots of folks sort of talk about, or they share their concern with me, is related to athlete performance, right? Especially if you're a young athlete, you want to manage the load and the training regimen and the hours. You want to make sure that you're diversifying. So, if you grow up and you only play baseball or you only play football, what are the physiological effects of doing that? And the consensus is sort of coalescing around this idea that that's not good. We don't want to specialize kids into sports too early, but now we can actually quantify that process, and we can predict the wear and tear on athletes' bodies, and we can actually prevent injuries using these types of machine learning and artificial intelligence algorithms. The areas that I think make most, I guess they align most with what I do day to day, is smart stadiums and sports marketing and consumer behavior. As I mentioned, stadiums are a little microcosm of an entire city, right? You have miles and miles of telecommunications infrastructure that you need. You have miles and miles of electricity. You have HVAC, right? Very sophisticated HVAC, especially now after the pandemic, and we want to make sure that ventilation systems are top notch. Optimizing food and beverage distribution, so you have almost like a little mini restaurant scene and a service industry baked into these stadiums. You also have to manage foot traffic into the stadium. Everyone's coming at the same time. Out of the stadium, everyone's exiting at the same time. You don't want people clumping in the stadium during the game, because that's not good for fan experience as well. You also have to worry about safety, security, and threat detection. This was a big part of my former life consulting for MLB, was how do they bring safety and security into the forefront of stadium operations. And that's probably the highest risk that the stadiums face and that sports and entertainment faces. When you're talking about putting a lot of people in a small area, you have to make sure that you're doing so safely, and not just from external, quote unquote, bad guys, but also moving forward, we're going to have to think about the public health implications of gathering people into a small space and the logistical challenges of doing so. And then last, you have to think about how is all of this going to kind of boil way down into the fan experience, because at the end of the day, modern stadiums are not what they were even 5 years ago, right? Modern fans, by that I mean, millennial and Gen Z fans don't want to sit in one place. They want a completely different stadium atmosphere, completely different stadium experience than prior generations. So managing and optimizing that is a whole new set of challenges. On the marketing and consumer behavior side, it used to be that sports marketing was basically managing an email list. And I think if you talk to, a lot of sports marketing executives, that's kind of what they would tell you, is that they rely really heavily on that email list. And maybe if you're lucky, you get open rates and you get read rates and you get click-through rates. Well, now managing the discussion that you're having with fans is completely fragmented. Now your fans are consuming your product, of course, through email updates and newsletters, but they're seeing your product on Twitter, they're consuming on Instagram, and all of the different mediums that Instagram has now. There's stories, there's reels, they call it. There's TikTok now, which, I'm not super familiar with TikTok, but a lot of my students use TikTok. And I know that it's just a huge platform for sports franchises and their constant managing of this conversation that they're having. Moreover, the types of posts and the types of communication have to be tailored to each medium, right? A post that will do well on Twitter won't do well on TikTok, or it won't do well as a YouTube vlog. And so you have to, as an organization, really think about how you're managing these multiple touch points. And now when you think about even digital ticketing, right, that's a huge touch point that people are sort of ascribing to the brand. If I go onto SeatGeek and try to buy tickets for a Yankees game, and it's a real hassle to do so, I might now have some negative brand affect towards the Yankees. And so that's something the Yankees need to be concerned with. So there's a whole number of touch points that are relevant when it comes to marketing and consumer behavior. And then, of course, spatial computing is the other area, and that's a broad term that I use to mean virtual reality, augmented reality, and mixed reality. So everything, all three of those kind of get pulled together under spatial computing. And I think that's going to be the next iteration of engaging fans whenever that market can kind of make itself known, and whenever we can put some a little bit more stringent bounds on the type of content that people want to consume virtually, and what's their willingness to pay for those types of products and so forth. So again, just to sort of reiterate, right, this idea that stadiums are a little mini city. I don't think, I guess I'll say, every data point on this that you see on the screen right here is super relevant if you're a stadium. So you have the environment that you're thinking about. If you look at the new stadium in San Francisco, right, Levi's Stadium, which I had the pleasure of visiting, about 2 years ago now. It's a beautiful stadium. It is entirely on one side. It's a giant green space, and they do that because the engineering benefits of having a green space on top of the structure is very beneficial from an energy use standpoint. I know that the new stadium in Seattle that they're building is, well, it's slated to be the first carbon neutral stadium. And so that's a huge logistical challenge. They've done some really cool things in Atlanta and their stadium design in terms of pooling water and water reuse and recycling of water from the Atlanta. Whenever like it rains in Atlanta, the stadium has this really advanced gathering system. Managing streetlights, parking, right? Parking is a huge logistical challenge. And so any of these sort of areas of urban design and development that you see on there are begging to be automated and begging to be optimized. And that's why we're seeing the deployment of all these things in stadium environments in particular. Okay, so here's just a quick sort of market map, if you will, of all of these different areas where there's a ton of startup and innovation activity. And I guess I'll say, 90% of these startups employ some sort of machine learning or artificial intelligence. Okay, so at the top left now, we have connected device and all the analytics that come with that. If your consumers are bringing smartphones and tablets to the stadium, which increasingly they are, you're going to want to know how they're using those, where they're using those, what are they doing on the screens when they're using them, and that's what that area is sort of operating in. One that I find really fascinating, I spend a lot of time thinking about, is crowd sentiment, which is the bottom left. Whenever you have, let's say when sports are operating at their peak, you could have what, 50, 60, 80,000 people in a stadium. And if you're a manager and you're trying to optimize your engagement with them and make sure that everybody's enjoying themselves and having a good fan experience, you could go around and do a survey, but that's very inefficient, and it requires a lot of non-automated processes, right? You have to send people out and they have to distribute surveys, or they have to send emails, and you have to ingest the data, and you have to run the statistics on the back end. It's a very human intensive, cost intensive, time intensive process. Well, with the new advent of machine vision and all of the cool things that we're sort of baking into machine vision, we're actually able to capture people's sentiment as they traverse an environment. So if you're walking through the stadium and the game's about to start, and you just got your beer from the concession stand, and you got your hot dog, and you're walking to your seat and you're laughing with your family, there are cameras situated somewhere in the stadium, and they can perceive, based on your behavior, based on your actions, based on your physical features, and even your gait, the way you walk, they can sense that you're having a good time. Likewise, if the team loses or makes a really boneheaded mistake or a decision, and everybody in the stadium is sort of sulking and they're walking around slowly, and they got frowns on their face, this same type of technology can sense that, oh, people are not having a good time and sentiment is depressed. And so that's something that I think is super cool. And I had a couple examples. Hopefully they're showing up. Let's see. Oh, here we go. So this would be one use of computer vision and crowd sentiment analysis here in the sports industry. This is from let me find them. This is from Advertima, which is bottom left. This is a screenshot of what they're capable of. So in a typical retail environment, their cameras, again, so from this view, we're looking at, through what a camera would see, it can sense that the woman on the left is female. She's about 38 to 40 years old. And she looked at that product. It looks like she's looking at some bottled water. She looked at those packaging for 12 seconds. And meanwhile, the guy on the right, we can see that he's a male. He's approximately 43, and it did not catch his view of the product, but it's working on it. Okay, so that's clearly very deployable in a stadium environment when you think about all of the retail environments that are becoming embedded in stadiums. Okay, Affectiva, which is another one of those startups I referenced. This would be from a camera positioned in like a public space, so perhaps at the entrance to a parking lot. You can see that, she's driving, but she's also looking at her phone, which is probably not optimal. So she's, 100% distracted. Her head is pitched, 20% down, right, from where it should be if she was looking at the road. She's not angry. Her eyes, it looks like, because they're down, they're cast at her phone. Sure, they're 80% closed. And then, apparently she's getting a text message that's beneficial. And so she kind of has like a smile on her face. And so she's expressing joy. And these are the types of analytics, these are the types of AI and ML that are being deployed right now in the context of stadium logistics and operations. So what can other industries learn? Again, like I said, I think sports and entertainment is leading the way in a lot of contexts. And so there are, I think, some key takeaways that other industries can glean from looking at the sports industry and from looking at how this industry has deployed machine learning and artificial intelligence. First and foremost, and I have a little bit of a soapbox about this, I really truly believe that sports and professional franchises were really the trailblazers when it came to relationship marketing. And that's because our business is fundamentally a human one, okay? You're selling a product that is discrete. You're selling a product that is scarce. You're selling a product that's intangible. At the end of the day, what you're selling, what people are buying, is a psychological attachment to a team, right? And that's completely irrational, right? There's no material financial benefit that someone can get from being a fan of a team. It's just it's pure love, right? It's completely inexplicable. And so sports teams, I think, for a long time have been very sensitive to that, and they've sought to build relationships. And in this new age, they've been enabled to build deep, meaningful, rich relationships with their consumers, with their fans, and they've actually put transaction type of behavior on the back burner, because they know that the longer you can maintain a robust relationship with your fans, the transactions will come. The transaction is the outcome, but you can't be outcome oriented. You have to be process oriented. And so that involved really leveraging all these different channels for delivering marketing material and for really going the extra mile to build relationships with consumers. And then incorporating, of course, feedback loops. I think in my discussions with a lot of sports industry leaders, every single one of them has talked to me about the importance of feedback loops. And they've used machine learning and artificial intelligence to automate the process of feedback, and they've learned a ton about their fans, and they've learned a ton about themselves in that process. Secondly, I'll speak a little bit here to workforce and human capital development. So if you look at, let's say, I referenced earlier, a soccer player and, her exertion on the pitch, right? She's running, she's sprinting, scoring goals, maybe, bumping into other players. That's taxing on the body. And so sports have been very sensitive to that, particularly in the context of, football and basketball, where, you get more physical exertion, and there's perhaps a higher risk of injury. And so I think that other industries can take these types of data and apply them to their own circumstances, right? So if you have a warehouse where there's a lot of physical labor required, I think if you're a company, it is incumbent upon you to make certain to quantify the physical toll that your firm's work is putting on your employees, and being very sensitive to that, right? And making sure that your employees are physically and mentally performing at their best. And in fact, empowering employees with the same data, right? So it's not just a, measurement exercise, it's a data sharing exercise. I think, I've talked to a ton of athletes who care deeply about their data and want to know more about their body and how they're performing, and want to know, that if they get 8 1/3 hours sleep, that's the optimal amount of time for their performance the next day. And so I think, applying that to other industries will be really enlightening as we move forward. So again, just really quick, I want to go through a short list of resources that, again, I have found really useful, and I hope you will too. Algorithms to live by and the master algorithm, those are on the ones on the left and the far right. These are super accessible, just like a nice introduction to the idea of machine learning and artificial intelligence and algorithms and that sort of thing. Algorithms to live by is really interesting because it takes the discussion of algorithmic thinking and processing, and it applies it to these everyday life decisions that we don't think about, right? Like, how long should you take trying to find a parking spot in a busy parking lot, right? And there's a whole algorithm that they say that first they define the algorithm, they talk about the use case, and then they talk about several other parallel situations where that algorithm, that rule of thumb can come into play. Let's see, Beta Ball and The Man Who Solved the Markets are both really great examples of how the quantitative revolution is changing industry. So Beta Ball, as the the front, the cover talks about is really focused on how the Golden State Warriors really transformed their organization over the past 10 or so years, and the process and the commitment that they went through to revolutionize their data gathering, data management, and deployment of things like AI and ML. And then The Man Who Saw the Market is about Jim Simmons and how he applied a quantitative mindset to the finance industry. We tend to think of the finance industry as inherently quantitative, and how could you make investment decisions without having quantitative support and backup? But surprisingly, before the mid to early 70s, it was a lot of gut instinct, right? There wasn't a lot of quantitative science behind it. Jim Simmons and his band of people at his firm and the iterations of firms that would follow really came in and revolutionized quantitative investing. Lastly, I'll say the two in the middle with the birds on them are really great resources. They're practical resources. So if you wanted to pick up a book that would teach you how to implement some of these techniques in your spare time on your own computer at home, those are two really great books that I use frequently and that I use in my classes. So I will highly recommend all these resources on here. And with that, that's all I have. So I'm glad to take questions at this point, and I will go ahead and I will close out my screen share here.
Thank you so much.
Sure.
I definitely want to read the Algorithms to Live By book and see if I'm
It's really good. It's
trying too hard for the perfect parking spot.
It's surprising how practical some of those algorithms they talk about are. Yeah.
That's awesome. So this is the time for the audience. If you have any questions, we're going to be using that Q&A feature of Zoom. It's located towards that bottom panel where you'll see the chat. So if you have any questions, we have, 5 or 7 more minutes. Let's see, looks like we just got a question. So someone said, I'm sitting here with 3 boys taking algebra and calc in high school, and it's nice to see that there's real world application to what they're learning. Can you give a quick background on how you got from freshman class in high school to where you are now, please?
That's a great question. I think a lot of people's journeys into machine learning and artificial intelligence, they do start, I think, with those basic kind of tenets, when you think about linear algebra, calculus, those were really the pieces of the puzzle that I did not realize were pieces of the puzzle until I started studying for a doctorate. And, so for a period of, let's say 6 or 7 years, this was knowledge that was in the back of my head that I'd learned, and it was sitting there, but I'd not deployed it. And so when I started studying for PhD, and I realized, oh, this is all the methods that we're learning are statistics. Then it was just a process of bringing that from the back of my mind into the forefront, and really augmenting that with all of the the econometrics coursework and things like that are part of a PhD. But the other thing I'll say too is that the field of sports analytics and machine learning has become so mainstream since I learned these things in high school that I think people's journeys into this topic, or these topics, will become much more fluid than my own experience and much smoother. And so there's lots of opportunities to continue to apply that knowledge and to do so, in ways that are, I would have loved to take a sports analytics class in college. I don't even think we offered one back then, and now it's almost mainstream. I think you can find a sports analytics class at just about every institution of higher learning. So that was my journey. It was not a smooth one. It was, one that was peaks and valleys, but I consider myself lucky to have gotten that exact foundation that you're talking about with calc and algebra.
Thank you. Another question, what language do you prefer to use?
So that's a good question too. If I were to advise, young people, if you're interested in learning this space, I would say there's positives and negatives to each programming language. Probably the most versatile is going to be Python. And the one that we use most in class is R and R Studio. And that's because it's a little bit more accessible. You can kind of show up day one and get a feel for R and R Studio. Whereas with Python, it's a much broader language meant to do a much larger breadth of tasks. And so you have to learn to think in Python first, and then you have to think in the language of statistics and then meld those together. It's more complicated. So I would recommend R to get started, and then maybe, move into Python down the road.
Great, thanks. Let me just read through this one a little bit. Where an organization is interested in developing new or novel applications of AI and ML to new fields, in your opinion, is it best to work with new developmental groups or to build from the ground up, such as high-level university math departments, or try to work with an established startup group who would need to pivot from their core focus? That sounds like the first part of the question, if you want to respond to that.
Sure. Yeah, I'll take a stab at the first part first. This is an interesting discussion to have. I think it's really one more related to business strategy. Interestingly, Jim Simmons and his whole group, if you read that book, you'll see he started out as a mathematician and a world-renowned one at that. He's been one of the few academic mathematicians to really transfer that skill set over into quote unquote the real world and use it and deploy it in a way that's that's benefited him and his firm. So I don't necessarily think that going to a math department would be bad because there's been success there before. But speaking as an academic, I know that if there's one thing that academics can be, it's concerned with our own little worlds, and we have a tendency to kind of live in that bubble. I would be more trusting of a startup that has a core competency in AI and ML doing something, because you can always redeploy those models or pivot those models to something a little bit different, or the application is a little bit different. And in fact, that's how a lot of the really great machine learning programs get built, is that they're built for one thing initially, and then they discover that maybe there's not a market need and they have to pivot or change direction. And so I think that's probably your better bet.
Cool. So you kind of ended up answering the whole question there.
Let's see. Right. Yeah. So when it comes to startups and being focused on their core direction, the culture of entrepreneurship is to fail fast, right? And so they say that if you're not trying something new every day in a startup, you're not learning, and if you're not learning, you're not evolving. So when resources are so constrained, there's a need to constantly iterate on what you thought you knew and to be open to new ideas. And so some startups can be a little bit myopic, but I think if you were to talk to the founders, I mean, all the founders that I've talked to have said, look, we have built something cool and interesting and fun. How it gets deployed, we're pragmatists about. So I wouldn't put them in that box of saying that they're too myopic about, using the product that they build.
Thanks. So it's just about 8:01. I mean, if anyone has any last minute question, it looks like someone said in the chat, very interesting, thank you. So we
Thank
could
you,
take one
Sarah. I
last
appreciate it.
question. Otherwise, that was good timing.
Perfect.
All right, maybe everyone got out what they wanted to ask. Thank you so much again for being with us tonight. Oh, Okay, that was another thank you. Never mind. False alarm. I
Sure.
thought it was a question.
Thanks so much for having me. This has been a lot of fun. I'm happy to talk anybody's ear off about this. So I put my contact information up there. My email inbox is open. Happy to have conversations with anybody about this. So feel free to reach out.
Excellent. Someone just asked in the chat, where can we get the recording? The library will post this to YouTube within the next day or two, since we've had permission to record it. So thank you for that. And more people are singing your praises in the chat. So I'll leave it open for another minute or two.
The Giants, yeah, I actually had an interesting conversation with their director of analytics, a guy by the name of Russell, and he's super. He was a former founder of a startup, and built some really cool analytics and machine learning stuff, and so they've got him working feverishly to get the team where it needs to be.
What are the odds that the Jets will go get the first draft pick? Pretty high right now, right?
I think that's about the most silver lining situation they can look for right now. So in that sense, they'll succeed.
Poor New York teams.
As a Niners fan, I don't consider myself too much better off there. We had brief flashes of brilliance, and then just about the worst injury luck you can ever hope for. So.
So do you have a leg up in all of your fantasy leagues, being a stats
Surprise.
professor?
Surprisingly, I think there's definitely a cost benefit analysis that I need to do when it comes to managing, fantasy sports and things like that, because, I'm sure I would love to go, an inch wide and a mile deep and, win a fantasy league. But then at the other end of that, I'm like, well, what's going to have to sacrifice for that? So my fantasy record, unfortunately, is nothing to write home about.
Oh, no. All right, looks like people are trickling out. So thanks again.
Great, of course.
I'll be in
Thank you
touch
so much.
tomorrow morning with the recording and everything.
Fantastic. Thanks, Kayla. Thanks,
Have a good
everybody,
night.
for attending.
Bye, everyone.